Hello everyone, Chris Tisdell here. Thanks for tuning in. In this presentation, I'm going to continue my series of videos on a beginner's guide to calculus. So thanks for tuning in. In the previous video, we looked at implicit differentiation, and I'm going to continue that with another example in this video here. So just to remind everybody, implicit equations are handy when this sort of basic y equals f of x model doesn't really work, or it's not appropriate, or it's not wide enough to cover what we're exploring. Now, an implicit equation is in this more general form. Okay, you can see we've got this big F, and here are a couple of examples. Now, because we're looking at calculus, we would like to know, can we differentiate this to form some sort of derivative? And we have a couple of underlying assumptions that, y is a function of x and big F is nice and smooth enough and things like this. And we saw that essentially you differentiate both sides of the equation. You use the chain rule where appropriate, and then you just do a rearrangement. Okay, so I'm going to do that in another example here. Okay, let me see if I can fit this on the screen. So we're going to differentiate both sides of this equation. In this example, this would be your f, big F. Okay, x squared plus y cubed minus 2. Okay, so let's differentiate both sides of this, and that's the first part of the question. And hence, so with this information, determine the equation of tangent line, not tangent line, tangent line at this point. Okay, so it's a two-step process. Okay, so let's give this a label and we will work our way through it. Okay, so let's differentiate both sides of this starred equation with respect to x. Okay, so the right-hand side is easy. This will just be 0 because the derivative of 0 equals 0. Derivative of a constant equals 0. Now we can just distribute this d dx across each of the terms in here, and I'm going to get the following. So yeah, we can do this extra line here. Okay, so there are some easy terms to handle here. This will become 2x. This will become 0. But what about this one? Well, the chain rule kind of says that, let me pull that down a bit. This can be written in the following form. Okay, so you can kind of confirm that just by covering up the dx's and imagining this right-hand side is a fraction, right? It's not really, but you can kind of imagine it being like that. Okay, so what this means is I can then differentiate this term here with respect to y. So let's write that down. So by the chain rule, this is going to be 2x, right? This then can be written in the following form. So this is where you're using the chain rule. Let me pull that over a bit more. This is 0. Okay, so now all we need to really look at here is this derivative here. Okay, so the derivative of y cubed with respect to y. So that's good. Now we can go through and do the differentiation, because this is going to become 3y squared. So I'm going to get 2x plus y dx times 3y squared equals 0. So the last step, rearrange everything and make dy dx the subject. So bring that over there and then divide that through. So it's going to be negative 2x all over 3y squared. Now look, you can see that the derivative has both x and y in it, okay, in this case. So that's the first part of the question, okay. Use the chain rule, we differentiated both sides, okay. So the second part of the question is, hence, so with this information, determine the equation of the tangent line at the point 1, 1. Okay, so let's work our way through that. So the equation then of the tangent line is going to be something like this. Let me see if I can squeeze it in. So let's say I have a point x1, y1. In this case, it is 1, 1. The equation of the tangent line is y minus y1 equals dy dx evaluated at the point times x minus x1, okay? So all we really need to do is evaluate this at our point and replace x1 and y1 with 1 and 1 respectively, okay? So for our purposes, x1 is 1 and y1's 1, okay? So the derivative when x equals 1 and y equals 1 is going to be negative 2/3. And this is going to be x minus 1. So now all I need to do is to clean this up a bit. So I'll take 1 to the other side. Yep. So we're adding this, it's going to be negative 2/3 x plus 5/3. So this then is the equation for our tangent line. Okay. So we're super happy. Great. Oh, okay, I'm just looking on the live chat. Panda Bear. Hello, he's written or she's written, what if y equals 0 for dy dx? Well, can't divide by 0, so the derivative would not be defined in that case. Okay, Panda Bear? So good question. What happens if y equals 0 here? Well, you can't divide by 0, so there's a problem. The derivative would not be defined there. Okay, guys, thank you for watching. If you have any comments, any questions, would love to hear them. And you can always put them in the comment section as well. So I look forward to seeing you for the next one. Hope you can join me. Bye.